Now in our last video here, last lecture, we talk about multiplying radicals. Before we actually look at some of these examples, I want to remind you a couple of the formulas that are going to be needed. The first one from elementary algebra deals with the square of a binomial. Recall that when you square a binomial, when you raise a binomial to the second power here, you always end up with three terms. Just a reminder, how do you generate the terms? Well, what you do, you take the first term of this binomial and you square it to get the first term of the answer. The middle term is the tricky one. What you do, you take two times the product of the two terms of these binomials. So it's 2 times A times B gives you the middle term. Finally, you take the last term of the binomial and you square it to get the third term of the answer. Now, how do the signs work? Signs are very easy. The sign of this middle term right here is the same as the one of the in between the two terms of the binomial. So that's the same right there. Now, the last sign right here, recall from last semester, that one is always plus. Okay, the next formula we'll talk about in class on Monday. Now, here's a new radical property. In fact, let me remind you of radical property R3, which was a multiplication property for radicals. But I'm going to state it now in terms of square roots only. It states that if you take the product of two square roots, let's say square root of x times the square root of y, then what you get the square root of the product of the radicands. This is how you multiply square roots. Whenever you multiply one square root times another, all you do is take each radicand, x and y, and multiply them together. That's the property that we gave um, that was called R3 for nth roots. But now we're just specializing it for square roots. And now we got a new radical property called radical property R6, and it's based on this property R3. When you square a square root, look what you get. All you do, all you get is the radicand. So in other words, the square cancels out the radical. So when you square a square root, you just get the radicand x. Now let's take a look at the examples. First example, all I do is use property R3 here. So take the 6 and I multiply it times a 2. That turns out to be the square root of 12. Now the only problem is that radical can be simplified. Now let's use a shortcut method. 12 is 4 times 3. I'm trying to find the largest perfect square factor of 12, which is 4. And the square root of 4 is 2. So this reduces down to 2 radical 3. Now, the hard part is making sure that you make sure you understand how I went from here down to here. Okay, the next one. All I do is use property R6. When I square a square root, all I get is the radicand. So the answer is 3. The next example, what I'm going to do, notice that I got this radical expression that has two terms or two radicals in it, and it's being multiplied by another radical, radical 6. So what I'm going to do on this one here, I'm just going to take the radical 6, and I'm going to distribute it to each radical expression within the parentheses. Now remember, use property R3. So radical 6 times radical 2 is radical 12 plus radical 6 times radical 3 is radical 18. As we saw in example number 1, radical 12 can be simplified as 2 radical 3. And then notice that radical 18 is not in simplest form. That one can also be simplified. I, I I think of 18 as being 9 times 2, and then the square root of 9 turns out to be 3 radical 2. Now these two radicals are not like radicals, so that is in simplest form. Now the next example here is worked out already. Let's take a look at it. Now notice that in the first set of parentheses I have two radicals. So it's like two terms, and the second one has two terms as well. So we make use of the FOIL method. I take the product of the first two terms. Let's see what we get. 2 times 3 gives me a 6. And then the radical 2 times radical 2 is going to give me radical 4. Then I do the product of the outside. And again, the 2 times the 1 that's sitting out front gives me a 2 here. And then radical 2 times radical 3, I multiply the radicands and I get radical 6. Now I do the product of the inside. 5 times 3 gives me a 15. And then again, radical 3 times radical 2 gives me a radical 6. And finally, the product of the last. 5 times 1 gives me a 5. Radical 3 times radical 3 gives me radical 9. Now, we all know that the square root of 4 is 2, and that the square root of 9 over here is 3. Notice that we have like terms in the middle here. Notice how the radicands are the same. The indices are both 2. So 2 plus 15 gives me 17 radical 6. Then I multiply the 6 into 2 to give me a 12. The 5 times the 3 is 15. And now notice that I have like terms. The 12 and the 15 add up to 27. And then I bring down the radical 17 radical 6. Notice how I write the answer. I write the term that does not contain a radical first, and I write the term with the radical factor last. That's the standard form whenever you write expressions where you have one without a radical and one with a radical. The term with a radical containing a radical is always written last. Or you could say it this way. The radical expression always goes last. The expression without the radical goes first. Okay, now the next example. Again, is another one here where I'm going to use this formula of squaring a binomial. So like we said, there's going to be three terms. So you can think of radical 3 as playing the role of A in that formula, and radical 2 is playing the role of B. So I get radical 3 squared same sign, it's minus, then it's 2 times radical 3 times radical 2 always plus radical 2 squared. Now I use property R6 that says when I square a radical, I just get the radicand. So this first term becomes 3. In the middle, there's a 2, and then I use property R3. It says radical 3 times radical 2 is going to be radical 6. Then I use property R3 again. When I square radical 2, I just get 2. And now I write my answer in the standard form. Notice that there's like terms. So I add the terms without the radical. That's 5 minus 2 radical 6. Standard form. Okay, the last example here. Again, it's another one where I'm squaring a radical expression. Again, I'll use this formula up here, square of a binomial formula. So radical 5 is playing the role of A. Radical 3 is playing the role of B. So you get radical 5 squared. Same sign. So there's a plus right here. Then it goes 2 times radical 5 times radical 3, always plus, and then it's the last term, radical 3 squared. Use property R6, radical 5 squared is 5. On the very end, radical 3 squared by property R6 is 3. And then in the middle, I use property R3 and I multiply the radicands of these two radicals and I get 2 radical 15. Combine the 5 and the 3, gives me an 8, and then I write the 2 radical 15 last. So there's my expression in its simplest form, 8 plus 2 radical 15. So that's how you multiply radicals. Be sure to do the problems that follow this as part of the lecture for Friday. We'll see you on Monday.